Hi everyone, my name is Ajay Mathur, and I'm an engineer on the app usage and discovery team within the Forge platform. And I've been lucky enough to be part of the Forge team even before it was released. So today I'm here to talk to you about making Forge a reliable, scalable, and secure cloud platform. Before we dive into these topics, let's take a recap of the journey of the Forge so far and then look at these topics from the Forge perspective. So, looking at the recap, before Forge, we offered only one cloud app extension framework called Connect. And in Connect, we had a concept that app developers would need to spin up their own app infrastructure, and our products running on our Atlassian infrastructure would interact with the app over the open internet. Now, this worked really well. This does work really well. We still have a lot of successful Connect apps on the marketplace. However, in this architecture, we see an app developer has to maintain a lot of things other than the business logic and accessing the customer data, like authentication and HTTP routes. Looking at this, we came up with a vision for the next version of App Extension Framework. And our vision was, what if the app could be part of the Atlassian infrastructure? And as an app developer, we don't need to worry about anything other than the business logic and data. So, keeping this vision in mind, we worked on it and we released Forge at Atlas Camp 2019 as a new way to build and run apps for Atlassian Cloud. And the way we achieved this vision with was by shipping Forge CLI. It was a CLI tool which developers would install in their machine and interact with our infrastructure with the following commands. For example, to create the app, just run Forge create and it would interact with our app registry framework, create a new app record, and return the app ID which would be stored in the manifest file of the Forge app. Next, with Forge deploy, we would bundle your app in local and interact with our deployment service, which would provision Lambda and additionally take care of provisioning it over client for the app to help with the authentication. Next, for app installation, with Forge install, again, the Forge app would interact with the app registry, which would create an installation record of the version of the app against the tenant requested. And to keep our system reliable, we asynchronously updated these records in our extension discovery services to be later used for invocation. And as mentioned, with our extension discovery service, maintaining the installation records and being a read heavy service, our products, whenever an app is triggered, interact with the service to get the details about the app, then call the invocation service, which would take care of also injecting secrets in the request, for example, auth tokens, and then trigger Lambda to invoke the app. Also, it would return response so that the app is rendered in the products. With these features, we Forge offered the following feature when it was released. For example, we had a sleek developed experience with Forge CLI. Creating an app, deployment, and installing an app was a breeze. We also had native app rendering. With Forge UI components offered on the release, the Forge app can be don't need to be rendered in an iframe, rather it can be rendered natively with the product. We also offered Forge triggers, which could be called over HTTP call that enable automation capabilities with Forge. And we also had managed auth where we don't need to worry about authentication and just by using as a or as a user calls, the authentication would be injected in the app. Since the release of the Forge usage has expanded and we have got a lot more use cases. So we have extended Forge and some of the features added since the release of the Forge are we have got a full Node.js compatibility now with the Node runtime v2. We also removed the consent screen with the simplified user consent project. We also have enabled team ownership where we have got multi-user app ownership model where different users could be added as contributor to the apps and also assigned a role. And also we have added a lot more extension points and increased the extensibility of the products and also onboarding new products, for example, Confluence and Bitbucket in early access. However, since the release of the Forge, we have added a should feature but the high level architecture of Forge has stayed the same. And at this point, I would recommend Brendan is talking tomorrow under the hood and in-depth about the Forge architecture to attend that talk too. So we started with this architecture of Forge, built feature around it, and we have been able to scale Forge from zero to over 773 Forge apps listed on Marketplace as of last week. And also, we have got over 19 million plus app invocations in a day in just last month. Now, we have learned and iterated throughout our journey to scale Forge platform reliably and securely. We have incorporated the learning into our process and decision making. In the next phase of the talk, I'm going to zero in on the platform engineering practices that help make Forge a robust platform for the thousands of apps that rely on it. So let's look at reliability first. Reliability, as a general, is defined as an ability of a system to consistently perform its intended function without failure or interruption. In terms of Forge, you can think reliability would be the app code gets triggered whenever a function Forge app is invoked. So the first thing we have done to achieve reliability in a Forge platform is within the engineering team, we have redefined the ownership model we have, which has enabled the engineering team to own the Forge builder flows end to end. So some of these would look like called Forge capabilities. So the Forge end-to-end flows look like for extension discovery, function invocation, and install apps. And it's the individual teams who own the flow end to end. Also, we have added monitoring to these flows, even though these flows are powered by separate services working together. We have added monitoring to these and SLOs, which are our service level objective to achieve regarding these. And we monitor them, and we have also got alerts and runbooks attached to them. The next one for reliability, we have got some of the operations in place. The first one is TechOps. In TechOps, our each service owner team meets at least once a week where we look back at the operations of the service from the last week. We look at things like ongoing SLOs, the vulnerability tickets, any PIR actions or incidents which are open, and also any PIRs which are open. And we identify action items, prioritize them, and get them done so that we can achieve a next level of operational excellence with the service. One level up to tech ops, we have got Torque. Torque is similar to tech ops quarterly kind of thing, where engineer leaders and which is an operational maturity review with the CTO leadership team, which is attended by org leads, senior staff developers, head of engineering, and product leaders. This is to awareness of the operational excellence concerns and also establish operational OKRs throughout the company. This is to make sure and but while developing the products, the reliability part is not left out. And these meetings also influence the product roadmaps so that reliability becomes the first class citizen. Last but not the least, in terms of operations, we have got war games. This is an activity, we do it on the team level, where a small part of the team would go and actually project the infrastructure of the service in staging. For example, bringing down the region or availability zone, and rest of the team would actually treat it as a real incident and try to resolve it. This activity has helped a lot to us to stay proactive and also practice scenarios which might happen in future and so that we can make the service more reliable. Second one, looking at scalability. Scalability would be ability of a system to handle increasing amount of traffic or data without degrading latency or stability. In terms of Forge, we can think, let's say we build a new Forge app and ship it on the marketplace, and we have a large customer install the Forge app the next day. From 0 or 10 install or 10 invocations, we reach to thousands of invocations. So for Forge platform, it's very important that we are able to maintain the latency and the performance of the Forge app even with the scale it achieves. To keep us ready for these things, We have got something called load testing, which we do at least once a quarter, where we actually test the services on 20% more load than the previous quarter's peak. Or if we have a new feature coming forward and we estimate a new increase in the traffic, we test these services 20% over that peak to make sure we are ready to handle the traffic increase in the traffic. Next, we have got scaling as a config. In each service that we build and ship in production, we have got scaling rules attached to the service, which are reactive to CPU usage, memory usage, latency, and or the queue sizes if they're using SQS or anything like that. This is to make sure the services can scale as the traffic goes up. Last but not least, we have got schedule scaling, where each service has got schedule servicing where, as per the region they are in the morning time, we increase the number of instances so that we can handle the increase in the morning traffic of that region. And this has worked really well as the as separate regions come online in the morning. Next, we have also got architectural decisions to make sure the systems stay scalable. And this is a really important part of it. The first one is scalable technologies. As we saw since the start of the Forge, we have gone with the choices of the scalable technologies, and we still do that today. For example, Forge storage is powered by DynamoDB, or and in the invocations are powered by Lambda. And also, all the services built on top of Forge, which enable invocation and deployment, are built with EC2 running behind an auto scaling group so that we can scale the services as the traffic goes up. We have also followed a service oriented model where each service is purpose built, and this has enabled us to scale them independently and also no cross impact on the flows. For example, we have got a separate service for Forge app invocation and Forge app deployment. So if there's any increase or any degradation in any of those, it's the blast radius stays small. Next, we have also incorporated multi-region support, and we also do tests like if one of the region goes down, the nearest region could actually take on the traffic for that region, and we do these with the availability zone failures and the region failure tests. Next, we let's look at the security first. So for the security, we had an awesome talk by Joe right before this, where it was security is measures taken to protect system from potential harm, damage, and unauthorized access. And Joel touched on threat modeling. So to talk in depth about threat modeling, it is done before even our development of a new feature starts, where we sit down with the security team and systematically analyze the architecture and the data flow of the new feature that's built to identify the potential attack vectors, and so that we can manage them. We have also got vulnerability detections. For example, he talked about eco scanners, but on top of that, we also have got scanners running on our services code, which scan our code and also configs to find any open vulnerabilities there could be. We have also inbuilt tenant isolation within Forge from start and made it a first-class citizen. For example, we released a new Node version, a new Node runtime with a full Node compatibility, but still we made sure that tenant isolation is built in on Forge. One of the important aspects of security is knowledge sharing, to be aware of the potential impacts that could happen. And for that, our security team has built a knowledge base within our company, which each team has got a training to go through with the potential attacks that could happen and how to mitigate them. We have also, and to spread knowledge across companies, we have got a concept of security champions, where a team member from each team is identified as a security champion, and they get position of representative of security team in that particular team, and they have responsibility of pushing the security best practices within the team. Additionally, to make sure the security champions stay ahead of the security issues, they have got regular meetings with the actual security team happening where they talk about the latest security issues, enabling team to find under vulnerability and understand secure development practices and then they bring this knowledge to the team and help us share it. However, we have got everything in place, but still sometimes incidents do happen. Our systems do have some degradation. So but the most important part of this is how do we respond to the incident so that it has less impact and we can resolve it faster. For that, we follow an incident response framework, which looks like this, where a vulnerability, when it's detected, it becomes a new vulnerability. And the detection could happen with alerts we have in our system and with our monitoring, or even any Atlassian or any customer detects it and reports it. Once it's detected, open communication across our company, and also if it's a custom impact, try to get it on the status page. Next is the fixing, where we first assess the impact. This is a very important step to find out the blast radius or the impact of the incident of how many customers impacted. This helps us figure out the severity of the issue. We also open up communication at this step, which is putting it on the status page for the public or for the end customers to see where the degradation is. Then we escalate or delegate as required by the incident to get it to the right team to get it fixed in the resolved state. Now, one important thing here is with the resolved state, it's not about just fixing the incident that it's moved to resolved. Once it's fixed, we actually monitor the metrics to make sure they are back to normal and the incident has been resolved. Once the incident happened, we have to make sure that the same incident doesn't happen again. For that, we have got something called PIR or post incident review. This is a document which the person who handled the incident creates and leads, where we look at the timeline of the incident, how it was detected, and why it really happened. Then we have got a concept called 5 whys at Atlassian, which helps us find the root cause of the issue. Starts with a very small question as why did this issue happen? And then drill down into whys until we find the root cause of the impact and go at least until 5 whys. We identify action items to make sure the similar vulnerability doesn't happen again, and those are prioritized accordingly to make sure we can close them and ship the feature fix. And last but not least, to make sure we build the trust between us and the partners, we do public PIRs for any high severity issue which happens and has a customer impact. Again, it's to be found at Atlassian's status page. Overall, to summarize my talk, just wanted to let you know like how at Atlassian we have set up our engineering practices to embed reliability, scalability, and security into the features and not make it as an afterthought. Thank you so much for attending my talk, and we'll keep iterating and keep on implementing practices and process we follow and decisions we make as the new Forge capabilities are built so that Forge platform remains reliable, scalable, and secure platform for hosting cloud apps. Thank you.